Hello, and welcome to Team 4's presentation for ISD 528, Advanced Design for Manufacturability. Here, Justin, Alex, Abik, Ankush, and myself walk through the analysis and redesign of an electric conveyor oven. An electric conveyor oven is a piece of culinary equipment that enables the continuous cooking of food by passing it through a heated cavity on a wire belt. The wire belt has variable speed, which enables this product to have high versatility and the ability to cook many different types of food. Its compact sizing is advantageous as it enables many different consumers to purchase and utilize this product. It is primarily composed of metal alloy and polymer-based materials, which are typically produced using sheet metalworking, machining, and injection molding methods. Depending on the model selected, this product can vary between 20 and 30 different components, and the estimated production volume is greater than 50,000 units, as its high functionality and easy-to-use operation make it a popular choice for customers needing to cook items in series and add some versatility to their cooking tools. The primary customers for this product are culinary professionals, which are producing food in restaurants, cafes, and diners. They would benefit significantly from the automation in the food preparation process. The secondary customers for this product are catering businesses, schools, universities, and hotels, which must produce food in abundance, as they require the ability to produce food at scale during peak periods throughout the day. On this slide, an exploded view of the product is shown. On the image on the left, we can see the wide variation in parts used to assemble this product. The parts that are used to assemble the product are detailed on the right and are 34 parts in total.
To identify all our functions, we created a fast diagram. The main function is to cook food, and our primary basic functions are to heat and move food. We also focused on assuring dependability, convenience, enhancing product, and pleasing senses. This is our first assembly sequence shown in a fishbone diagram. It consists of 6 sub-assemblies, such as the base support, belt gear assembly, main body, motor assembly, switch panel, display panel. We also have 3 individual components, such as the unloading tray, loading tray, and heat shutter. All of these components come together to form the assembly of the conveyor oven. For our second assembly sequence, our fishbone diagram still consists of 6 sub-assemblies, but the main difference is that the fan and the top cover were removed from the main body and added at the end of the assembly process. This is because the fan and the top cover could be assembled at any point after the main body, and we are depicting it here at the end of the process.
Our assembly sequence comparison concluded that sequence number 1 was slightly more favorable than sequence number 2. This was driven by 2 main areas. One was ease of assembly in parallel, because sequence number 1 includes a greater number of parts earlier in the assembly process as part of parallel subassemblies. The second driving area was ease of testing subassemblies. By including a greater number of parts earlier and therefore completing the subassemblies earlier in the process, sequence number 1 allows for earlier and easier subassembly testing. Our team mapped our 18 terminal level functives with our 34 parts via the function component mapping matrix. The functive that required the greatest number of parts to fulfill was reinforcing the structure at 16 parts. 2 of our parts tied for fulfilling the greatest number of functives. These parts were the heater tube and control module, each fulfilling 5 functives. We used principles presented in class lectures along with our best engineering judgment to generate our initial bill of materials and rough cost estimation for each part, and therefore our total unit production cost for our oven. We expect the price of about $880 per oven can be decreased via design for assembly and design for manufacturability.
With respect to the product family design, our team differentiated the functions derived from the fast diagram for both the consumer groups, with basic functionality and unique or improved features such as illuminate food and guide food. Moving forward to the component commonality modules such as the light bulb, that is to obtain enhanced illumination and improve guidance of food through the modification of the loading and unloading trays. Based on the assessment of components into manufacturing and functional importance and elaborating on the results from the quad chart, components like the lower panels, heater mounting plate, side panels, top cover, fan and heat shutter would be eliminated. Parts like the bottom panel, collection tray, housing, loading tray and unloading tray would be redesigned with design for manufacturing assembly, and rest of the components would remain same with design. Elaborating on the product family design module comparison, both the offerings of the conveyor oven product are shown here. In product 2, the new and redesigned components such as the LED, the loading and the unloading tray are assembled and demarcated to represent the overall differences.
Here you can see the interface between unloading tray and the main body. The unloading tray is attached to the main body using fasteners. In the overlapping image, you can see the dimensional differences between unloading tray 1 and unloading tray 2. Unloading tray 2 has been designed with a bigger dimension to increase its capacity. This is the loading tray, which has the same interface with the main body as in the case of an unloading tray. Here again you can see the dimensional differences between two loading trays. The loading tray 2 has been designed with the bigger dimensions and steep angle in order to increase its capacity and self-fitting feature. Here in the second image you can see for the secondary customers we have provided two LED lights, one on each side of a loading tray and unloading tray. And for the base model we have just given a dummy plate in order to use the same top cover in both products. These are two assembly diagrams with a delayed differentiation in second. We are going to save logistic and assembly cost.
This concludes our presentation for the analysis and redesign of an electric conveyor oven. Thank you for your time, and what questions do you have?